Alright, this is that promised video on Ohm's law arrow logic. So on the screen already is a very common thumb rule of Ohm's law, which is voltage over current times resistance. So another way to look at this would be E is equal to I times R, where voltage is equal to current times resistance. So sometimes when figuring arrow logic, that is the easiest way to look at the formula, and I'm going to show you why. So there it is again, E equals I times R, and when I am trying to teach this to new students, or sometimes even trying to reason it out on my own, I will use this particular technique. And so that is to use very simple math and place it on my voltage, my current, and my resistance, and then vary those numbers based on what the arrows are doing, what the numbers within the circuit are doing, and that way determine what my component is doing without even using any real numbers or calculations. So let's try an example of how it works. So let's say I have a formula where current decreases and resistance stays the same. So if current decreases and resistance stays the same, and I put it into that formula, that very simple math formula that I use, and I say, okay, current goes down to 1 and resistance stays at 2, well then I can see really easily that 1 times 2 is 2. So that voltage actually goes down from my original formula. Let's try another one. If I have current that stays the same and resistance increases, and I put those numbers into my simple math formula, I see that current staying at 2 and resistance going up to 4 gives me an increase in voltage. All right, another example. So current stays the same again, but this time resistance goes down. I put it back into that math formula that I've been using, and I get 2 times the lower resistance now of 1 gives me 2. So my resistance value has gone down. And again, another practice. Current goes down this time, and resistance goes up. So voltage actually stays the same. One more time, and we have current going up and resistance staying the same, which means that our voltage is going to go, that's right, good guess, up. Alright, I hope you enjoyed this little trick on how to manage arrow logic within your circuits math. It's a great little shortcut to use, especially in your changed values or your shorts. For instance, if I have a series circuit with 3 resistors and I short around one of them, I would expect resistance to go down, whereas incoming voltage will stay the same. So if resistance goes down, incoming voltage stays the same. I would expect current to go up. You can use this in parallel. So if voltage stays the same, which we know it does in parallel, then and my resistive value within the branch goes up, I would expect current to go down. All right, I hope you guys enjoyed this little moment on Ohm's law arrow logic. And next you'll see parallel circuits.